All right, so welcome back, everybody. How's everyone doing? Are you guys liking the in-person transition, or did you prefer online? More convenient? I mean, most of you are here in person, so I suspect you like in person. Um, so did anyone look at this JTunes example? Just a show of hands, how many people looked at it last night? One person, okay. What, sorry? Okay. Oh, you're Ahmed. Okay, nice to meet you, Ahmed. So last time we talked about, so we went through basically, the basics of the MIS. We talked about things like set notation, quantifiers, and sort of the building blocks. And then we did a couple examples. We wrote them up in LaTeX, and then we translated it to code. But last time what we actually did was they were like very isolated examples. We didn't put together like a full MIS and a full specification. They were like taking simple examples of, summing up elements in an array or finding all elements that are distinct or something like that. So in this tutorial, we're going to look at a full specification. So we have this JTunes application. So it's like iTunes or Spotify, like some music management software. And basically, we're going to build out this module. We're going to, write the spec for it for a playlist class. So a couple things, and I'm sure you guys have seen this by now, right? This table and all of this stuff. So basically, we're going to assume we have this class name song. So basically, just assume it exists. It does what you would think it does. We don't have to worry about it. We're going to focus on this playlist module. So a couple things, it doesn't export any types. It doesn't export any constants, but it has a number of access programs. So basically we have our constructor, which takes in 2 arguments. So it takes in a sequence of songs and it takes in a string. So we'll look at what those actually mean in a second. And then it returns a playlist and it can throw in a possible exception. And then we have an add song, remove song. We can shuffle songs randomly. They should actually be named shuffle song. And then we can play the next song, we can play the previous song, we can get the size of the playlist. So, things like you would have in Spotify, you can shuffle, you can, reorder your songs, you can play the next song, go back, whatever, right? So those are our sort of methods. And oops, that's too much. So we have a couple of state variables. So basically we have 3 state variables. They're pretty intuitive. So we have songs, which is a sequence of songs. So we're going to maintain this internal list of songs. We have a name, which is the name of our playlist. It's just going to be a string. And then we have this variable called current song pause or current song position. So essentially, this is like an index of where you are in the playlist. So you can go back and forth. So this is going to be an integer. And because this is an index, we're going to have a constraint on it. And the constraint is that, because it's an index, it has to be greater than or equal to 0. And it has to be less than the length of songs. So that should be pretty straightforward. And then we have a couple of assumptions. So we can make the playlist class with an empty list of songs. So you don't have to pass it, a list of songs that has at least 1 song. You can pass it an empty list and then add songs using the add song method. We're assuming that the constructor is called before any other method, and you can only call the constructor once for each object instance. That's like, pretty straightforward stuff. As for shuffling, so we're just going to take a simple approach. We're going to say that we're doing shuffling by, randomly swapping elements. So we pick 2 random indices and we swap them. And we're going to say that a list is considered shuffled if at least 2 elements have swapped their position. Okay, well, we'll talk more about that. And then assume that this provided random int function works as expected. So we have this function down here, which is random int. Assume that it works as you would think it does. So you have a start and exclude. I'll talk more about this, but just assume this is something that exists and it already works. We don't have to worry about it. And assume that the song class exists. So what we're going to do now is take those methods and I'm going to get you guys to figure out what the transitions, outputs, and exceptions are going to be. So yeah, anybody want to take a shot at the first one for playlist? What sort of transition is, what transitions are we going to have? And again, transitions are basically when your state variables transition from one state to another. So it might be updating a variable's count, updating a string, something like that. And again, this is our constructor. So, take a shot at it. Well, any ideas? What transitions might take place here? And again, you want to think of your state variables, right? Constructor is usually where you initialize your state variables. So that's like a little hint. So again, we have these 3 state variables and we have our constructor, which is usually where we initialize our state variables. So any ideas what's going to happen in here? Again, S is a list of songs and P name is just playlist name that we provide to the constructor. Anybody? Yeah. I can't hear you, sorry.
So the playlist name as name?
Yeah, so basically we're going to do pname or name equals pname. That's one of them. What else would happen here? And let's start typing these up. Yeah, so as someone mentioned, one of them is going to be in here. Well, I'm going to go down here. Access routine, yeah. So transition, one of them is going to be name becomes pname. What else? So that's one of the state variables. There's two others that we need to initialize. So what is that going to look like? Anybody? Yeah. Yeah, but you know, we do have a parameter in the playlist constructor as well, which is s. So yeah, you're close though. But you want to take into account that parameter you're passing as well.
Add the S, which I'm assuming is a song, to the list of songs.
Yeah, so S is a list of songs. It can be empty or it can have a list of songs. So essentially, our internal list songs becomes S. That's what we're getting at. So songs becomes S. And there's one other thing. Again, there's three state variables. So we looked at what happens to name. We looked at what happens to songs. And there's the current song pause state variable. What's going to happen with that? Yeah, we're just going to set it to 0, right? We're just going to assume we start at the beginning of the playlist. So, you know, if you open the playlist, you play the first song. So we're going to do current song pause. That gets initialized to 0. Is everybody clear on this so far? You know, this isn't something you've never seen before. Dr. Macchio has done this in lectures. Okay, cool. And then the output's just going to be self. That just means you return that particular object instance. And I don't think this method had any exceptions. Oh, we do have an exception. Yeah. So what do you guys think is you know, under what conditions would you throw an exception here in the constructor? Well, you know, this is your constructor, so this is the first time you're creating, you know, the playlist. So nothing really exists at this point. Yeah. Well, okay, yeah, so you're right. But the thing with the MIS is we specify what the actual types are. So we sort of assume that we get the right types. And same thing in Java, right? You specify the type in the method signature. So you're assuming that that's passed correctly. That's not something you have to deal with. But you know, what sort of maybe you can think of what's an invalid sequence or invalid string that you could pass to the playlist? Well, we assume that it can be empty. That was one of the assumptions. Yeah. Sure. And any other sort of more intuitive ones? Can you have an empty string as the playlist name? Yeah. So if you have like so exception is, oops. So if you basically, if p name is or basically we're going to write it like p name. Let me put this in math mode. So if you do p name, if the length of p name is 0, which is a playlist name, that's going to throw an exception, right? We don't want an empty or a playlist that has an empty string as a name. So that's one of them. So I think that's all for playlist. We're just going to initialize all of these. What about add song? Any ideas for add song? Anybody? Yeah.
Songs plus equals.
Songs plus. So yeah, I think you're right. I'm not sure if in the MIS you can use plus equals, but you can just use plus, like songs plus the new element. Yeah, so that's right. Is there anything you have to take into account before you do that? Well, we're assuming that we're passing the right types, right? So do we want 2 songs in the playlist? Like, do we want a repeated song in a playlist? Yeah, let's assume we don't want that. I should have stated that. Yeah, so essentially you don't want it to be a member of songs already. Yeah. So you can state things conditionally. So let's do it like this. There's 2 ways of doing this. You can use just if else, or there's like another notation that I'll show you. So we can just do if, and actually, does anyone want to take a guess at how we state this? So we want to state that this past song parameter is not a member of our state variable songs. Anybody? So we're going to do not in. So that's the notation for when it's not a member. So it's just like the member of symbol with a slash through it. If not in songs, and then we're going to do, what are we going to do? We're going to do songs become songs plus the new song that we just passed. So I think you've seen this notation for lists or sequences. That's just how you can concatenate stuff. And oops, this down here. And then otherwise, so this is one way of specifying like conditional transitions. Otherwise, you know, we can just say like songs plus just an empty list. Just basically nothing happens in that case. So that's what that looks like. So if song is not a member of songs, and this should have parameter here, song. So if song is not a member of songs, recompile this, then songs becomes the current list plus this new list that has a single element, which is a song that we just passed. Otherwise, we can just do songs become songs plus just an empty list. Okay. Is there any exceptions here? I don't think there was. So add song doesn't have any exceptions. Okay, what about remove song? Any ideas for remove song? Yep. So this is a sequence, not a set. So I actually don't know if you can do that, but I mean, you're right. You're on the right track because I actually haven't seen like sequence difference notation, but I have seen this other notation. It's referred to as sequence building notation. So it looks like this. Like if you want to return, let's say, you want to say something like songs becomes maybe like, you know, X is a type song. And then you have basically it's similar to the notation we've seen already, but you just put sort of these angle brackets around it, and then you can say something like X is a member of S, and X does not equal the past song or something like that. So this refers to as referred to as the sequence building notation. So hopefully everybody can see that. I'll type it out later as well. So that's the notation we can use for sequences. So for sets, we can just do like union or add or subtract them or something. For sequences, we can do this. So basically, we're going to say songs becomes basically, so we're going to have S, and S is in, or S is of type song. And then S does not equal the past song. And we have S is a member of songs. So let me show you what that looks like. So basically, this is referred to as the set sequence building notation. So essentially, this is saying that songs transitions to this new sequence such that for all S in that new sequence, S is not equal to song, which is the one that we passed, and S is a member of songs, which is the list that we already have. Okay. So any questions on that? Any questions? Okay, good. I don't think there was exceptions for this method. Oh, we do have an exception for this. Yeah, so when would we throw an exception? So if you're removing something, yeah. Yeah, so how would we state that? So if not a member of songs, right? Yeah, so something like song not in songs, then that implies we're just going to throw like a value error. So that's the notation for exceptions. Essentially, you state some, oops, not in songs. So basically you state some Boolean condition, and then you have this implies arrow, and then that implies whatever error that you want to throw. So value error, illegal argument exception, whatever. So that's how you state exceptions. Okay, let's move on to the next one. Shuffle random. Any ideas on this one? Anybody? So this one's probably the most complicated one. It's not super complicated, but probably the most one out of all of the others. So again, we do have that random int function, and we said that we're shuffling songs by swapping two random indices. So that's like a hint for you guys. Any ideas? And I guess another hint is you can again use that sequence building notation that we've seen like that and over here. Anybody? Yeah. Yeah. Well, you can think of this think of it like a for loop. So if you're shuffling an array, you write this for loop, and then you're gonna have for int I less than length of playlist, whatever, and then you're gonna get some random index, and you don't want that index to be equal to I because that's your current index. You want to swap two elements, and then you're gonna swap that with I. So think of it like you have a for loop, and then you generate some random number or some random index that's not equal to the current variable I in the loop, and then you're gonna swap them. So think of that, and then translate that over to the MIS. And as you mentioned, yeah, we're going to use this sequence building notation. So we're just going to start off with our angle brackets. So anybody? And you don't have to give the full answer. We can go through this iteratively. So I can start it off. We're going to start with I, or whatever you want to call it, and this is going to be an integer. So this represents an index, and I is going to be from. So basically, we're saying that songs becomes this new this new. Let me compile this so it's more clear. So we're saying songs becomes this new sequence when we're using that sequence building notation. So we have I, and again, it's going to be the shuffle list is still going to be the same size. So I is still going to be basically from 0 to what? Yeah, we can call size. What's another way we can get the size? Yeah, of what? Yeah, so we would do of songs -1. So this means I goes from 0 up till length -1, and then we're gonna have some some predicate. What is that predicate going to be? So this is where you're gonna have to use that random int function. Anybody? And I did miss one thing for this for a move song. Let's see. So this should be :s. So basically, the way you read this is S is of type song. S does not equal the song that was passed, and S belongs to songs, and the actual element that we want is S. It's very similar to the set notation that we've seen. So, anybody for the shuffling function? So basically, we know our variable. We know its range. It's from 0 to length -1. What's the actual? What's going to go after this colon? Yeah. Okay. And then what? So you're saying random int, call a random int function, right? No, x and then index it. Why would you index x? Songs, yeah, exactly. Yeah, so you're going to basically index songs, add some random index, and that random index is provided by that random int function. So we have random int. Whoops. Yeah, thanks for pointing that out. That should be just S. So over here, we're going to call songs at a random index. And again, if you look at the random int function, we have a start, end, exclude. So that means generate a random number from start to end inclusive, and then exclude the particular number that was passed. So basically, we're going to start from 0, and the end range is going to be length of songs minus 1, because you can pick any index in the whole playlist, and then you want to exclude the current index, which is I, because you don't want them to be the same. Otherwise, you wouldn't shuffle necessarily. So let's compile that. So it should look, and this should be random int. So we're going to call that random int function. And let me do this. So this is a little thing you can use, math it. It just makes like words nicer in math mode. Yeah, so that's what that looks like. And let me move this one line over so it's more clear. So any questions? No, it won't always work, and that's okay, because in Java there's actually a provided shuffle function. It's called collections.shuffle, and that doesn't guarantee shuffling always either. So this is good enough, because you can imagine you might end up, you swap two things, they go back, you could possibly swap them back, right? So this won't actually always shuffle, but it's good enough for our purposes.
Zero to 10, yeah, 0, 0, 10, and then 0, 0, 0, 0, 0, 0.
By 0, 0, 0, you mean like the random index?
Yeah, some random song index.
Yeah, so it won't actually, it's not guaranteed that it'll always shuffle. And that's okay, because that's how the Java shuffling method works as well. It doesn't guarantee always shuffling. Duplicating elements?
Yeah, because the only thing that we're including is the element of, so for element I, the only thing that we're excluding is element I. We could get element J, which is set J to some number. We get that over and over and over.
Right, but each time we're going to exclude like the current one, so you won't actually duplicate anything.
Yeah, you're only excluding the current one, so you could get the first one for this one and that one and that one and that one and that one. Keep forgetting, right?
I'm not sure.
Okay, so imagine an array of length 10. The first song, we'll just get some random song.
Sure.
For every other song, we're excluding, so for index 1, we're excluding index 1, but we're not excluding index 0, so we could get index 0. And the same for index 2, we could still get index 0. And the same for index 3, we could still get index 0.
Right, but what you're doing is, okay, let me draw this out. You have something like this. If you have, let's say a list of 3 songs, so that's 0, 1, 2. So you start over here, right?
Yeah.
That's clear. And then you're gonna find some random index excluding this. So 1 or 2.
Yeah.
So let's say this. We'll just number the songs 1, 2, 3, or maybe 10, 20, 30, just so they're not the same as the indexes. So then we're gonna swap this with either 1 or 2 because we're not including 0. So then, after shuffling, you might have something like, you might swap these 2.
We're not swapping them, are we?
We are swapping them. Okay, so swapping isn't exactly clear here, but in code, you would actually end up swapping them.
Okay.
I think that's what you probably missed.
Yeah.
Yeah, because you just imagine like a for loop, and then you go through generate random index, swap them.
Yeah, because in this implementation.
Yeah. So the way you read this is, I goes from 0 to songs minus 1, and then you're gonna pick some random element. Yeah, so we missed that swap part. Yeah, you're right. Yeah, so swap isn't mentioned here, but that's what you're actually doing. So again, you'd swap it, you'd have something like that. Then you'd go through, so you never actually duplicate anything, as long as you're swapping. Yeah. But yeah, that's a good call. The swapping isn't obvious here. I'm not sure how you would state the swapping.
You just have 2 indices that you swap. You have 2, like song at I and then song at J, and then you swap them. But you need a temporary.
Yeah, but I don't know how to state that in MIS terms, We'll come back to this. We'll probably refine it. But is the shuffling thing clear? Any questions on shuffling? Everybody's good? All right. What about play song or play next song? So what's going to happen in our play next song? Anybody? So again, we had that state variable named current song pause or current song position. So if you want to go to the next song in the playlist, what do you think is going to happen? Yeah. Yeah, we're just going to increment it. But it's not that straightforward. There's like certain edge cases you have to think about. So anybody other than Ahmed want to answer? Anybody? So the simple case is just incremented by 1. When is incrementing by 1 a problem? If you're at the end of the list, right? So what should you do if you're at the end of the list? Yeah, you can just go to this first song, right? That's usually what happens in like Spotify or something. So let's write that out. So basically, we have to state this conditionally. So we can say something like, if current song pause plus 1 is less than the length of songs. So, if we go over 1 and that's still less than the length of the songs, that's okay because we're not out of bounds. Then we can do current song pause becomes, let's just do this. Current song pause plus 1. And then otherwise, let me compile this first. So far we have this. If put it back here. So if current song pause plus 1 is less than the length of songs, that means we won't be out of bounds, so we can just increment it. Otherwise, we'll just go back to 0. So we'll just do current song pause becomes 0. Okay, so relatively straightforward. Okay, what about a remove song? And I don't think this one had exceptions. Play next song. Oh, it does have an exception. Oh, so we do have an exception for play next song. When do you think there's going to be an exception?
There's no song.
Yeah, when or in MIS terms, how would you state that?
Length of songs is 0.
Yeah. So basically, we're going to say exception. Oops. If the length of songs is 0. Let's do like this. That implies a value error. We'll just throw a value error. Okay. Okay. What about previous song? So we have this previous song method. What is that going to look like? Anybody? So this is going to be similar to play next song, but slightly different. Anybody other than Ahmed want to take a shot? So in next song, you're just going ahead, which looked like this. If you want to go back, what would you do? Yeah, instead of plus 1, we're just going to do minus 1. And what about what's sort of the edge case for that one? Yeah, in MIS terms, what would that mean? Length minus 1, right? Yeah, good. So I'm just going to copy that over. And it's over. So basically, if current song pause minus 1. So, well, what's the condition here? So before it was plus 1. If plus 1 is less than songs, then we're good. We're in bounds. What if you're going backwards? What do you have to check? not equal to 0. Almost.
What is this the like?
This is when you're going back. So when you're playing the previous song.
Okay, well,
Greater than or equal to 0. Because you can have any index that's 0 or positive, right? 0, 1, 2, 3, and so on. So we're going to do current song minus 1 is greater than or equal to 0. Then we basically decrement it by 1. Otherwise, we're just going to set it to the length of songs minus 1, which is the last index. So if you go back, if you're at the first song in the list, you go back, you can just play the last song. That's usually how it works. And then there's going to be an exception. Should be pretty obvious what the exception is. Anybody?
same situation.
Yeah, if there's no songs, right? So exception, length of songs is 0. Then that implies failure. Okay, and the last function is, anybody want to take a shot at the last one? What would the output be for size? This is like the easiest question. Yeah. Yeah, that works. Or if you want to do maybe more, MIS style, maybe using some notation that we've seen, what would that look like? Yeah, so yeah, like using like a for loop. Yep. So basically size, we can either just do simply, we can just return the length of songs. So that's like the simple one. Oops. I'm not used to writing on this small keyboard. Or we can do this slightly more complicated. We can do, basically we can say output is out, and then using the notation we've seen, we would do basically, we would have plus, and then anybody know? So again, we're using that set notation.
Like the end is going to be.
Yeah, so let's put that. That's the end. We do have that sort of vertical bar in the middle. So there's two things that we need to put. Anybody? So again, we want to specify some variable and its type, and then we want to specify the sort of the predicate, and then we're going to add 1. So what is the our variable, and what is its type, and what's the predicate for it? Yeah. Yeah, perfect. So X is a song. So that's the type, and X is in songs. Our list of songs, and then basically we're going to add 1 for each one. Yeah, so that's what that looks like. Okay, any questions? Anybody? So again, most of them are pretty straightforward. The shuffling one, the swapping isn't very clear, but it'll be more clear when we actually write up the code for it. And we dealt with all the exceptions, the transitions. Did we miss anything? Any questions? So for the shuffle one, actually, there's an alternate way you can write this. You could do something like this. So I wrote this out beforehand, which is slightly more clear. Yeah, so let's write this out. So let's see, shuffle. There's a shuffle method. We can do something like basically songs becomes a list such that, so songs becomes, let me actually compile that. So songs becomes S such that, and then you can state a property about S that would make it clear that it's shuffled. So what would that look like? Any ideas? So again, we said that shuffle, we consider a list shuffled if at least two elements have swapped their position. So what can we do here? So we want to say S, or songs becomes S such that some property of S holds. I'll give you a hint, you have to use a quantifier here.
Exists a element where that element beside it is not the next value.
Yeah, that's very close. Essentially, there exists at least one element in S such that S at I does not equal songs at S. At least two elements are not in the same position. So that's considered shuffled in our case. So anybody remember the syntax for that? For the exist quantifier? So we're using the existential quantifier. Yeah, so this is / exists. And then basically we want to say something like I is of type. So we're going to basically treat this like a for loop. I is an integer, and I is going to range from, what's it going to range from? 0 to? Yeah, 0 to songs, length of songs minus 1. And then basically the property, what's the property you want to state? What's the predicate? Yeah, that's perfect. Yeah, that's exactly what I had. Yeah. So it looks like you guys figured that out. So S at I does not equal songs at I. So I think this one's slightly better than the previous one. And let's just put parentheses. So any questions on this? So basically, again, you can imagine you have two lists that, you know, they have the same elements, but at least two elements are not in the same position. So that's considered shuffled. Okay. Any questions on this? Is it clear? Anybody other than Ahmed and, sorry, I don't know your name, but other than these two, anybody have questions? Don't mean to single you guys out. Anybody? Everything's clear? So let's go ahead and code these up. Let's go to this code. How's the first assignment, by the way? Hard? Easy? Nope, nobody started? Okay. Well, when's it due?
Next Friday.
I see, I see. He's pretty generous.
He's not allowed to make things due on reading week, so
Yeah.
allegedly.
I mean, it's nice to get it out of the way before reading week.
Okay, we got 2 midterms coming up.
When's the midterm for this class? After reading week? Oops, not code. Let's call this song. And let me open my terminal. All right. So for the song class, we're just gonna have, basic class song. Again, I said assume that this sort of exists. We're just gonna assign it like a name. Keep it simple. Let's just say private string name, and then we'll do public song, which is just our constructor. We're gonna have a string. Let's just call it song name, and then name equals song name. So that's all this class is gonna do. Just keep it simple. The one we want to focus on is the playlist class. So again, we had 3 state variables. Does anybody remember them? Anybody remember the 3 variables we had for playlist? Sorry? Yeah, so we had songs. So songs is just going to be, it's basically going to be an array of type song. So we're going to say private songs or private array list. of type song. So we created this song class so we can, use it as a type songs. And then let me import array list. Java.util star. And then there's two other variables, state variables. Sorry?
Name.
Yeah, so we had name, which was a string, and there's one other. Yeah, which was the type. Yeah, so it's an int. So private int current song pause. Okay, so then we're gonna have our constructor, public playlist. This had two parameters. So one of them was s, which is an array list of songs. Array list song s. And then we had the p name, which is a playlist name. String p name. So what's gonna happen here? This is our constructor. What happens in the constructor? Anybody? Well, we're gonna assign the we're gonna do name equals p name, and we first have to initialize our variables. So we have to do songs is new array list, because over here we just declare it. We don't instantiate it. So we're gonna instantiate it, and then name equals p name. And there's one other thing we have to do. Well, there's two other things. One of them is easy. You just do current song pause is 0. There's one other thing we have to do. Is this valid? Well, I'll tell you it's valid. Does anybody know the problem with this? Yeah. So what ends up happening?
Once if you modify either inside the class, it'll modify s outside of it, or
Yeah.
vice versa.
Yeah. So essentially, s is a pointer to some array list of songs, and then we're setting our internal list to that pointer, which is bad because anytime we change either of them, the other changes, and we don't want that. We want sort of a unique copy within our class. So you have to manually copy it. So how would you manually copy it? Yeah, just a simple for each loop. There's also, I think you can do s.clone, which is the built-in method for cloning, but we'll do manually just to, just as a exercise. So has anybody seen the for each loop in Java? Okay. So we can basically do like, we specify the type, song, and then the list we're going to iterate over, and then we do songs.add song. Okay, so that's all for the constructor. So then we had add song. So again, add didn't return anything. It was just a void method. What's the argument? Yeah, just a song of type song, right? You guys are probably tired of hearing the word song over and over. So anybody remember the MIS for this? And maybe I can bring that up side by side. Let's see. Zoom in a bit more. Let me close this. So how are we going to translate this to code? Anybody? Yeah. Yeah, let's see what the API looks like. So basically we're going to start by saying if song not in songs, then we're going to do songs.add. Yeah, songs.add song. Oops. And we'll fix this in a second. And then, oops. Otherwise do nothing. So in this case, we don't have to explicitly write out song.add empty list. And this is, let's see what the API is. If s dot, not auto completing, contains auto complete.
Stuff.
I think my window is messed up. Okay, I think it is contains though.
Does it matter if you do like songs or?
You can do both. So you can do this, which is a reference. It's like a pointer to the actual object instance. You can do this dot songs, or you can just do songs directly. songs dot, yeah, contains. So if that does not contain, we don't want any duplicates, then add it, otherwise do nothing. Then remove is similar. So we're gonna have public void remove song. And we want to remove a particular song. So that's really easy. We're just going to do, well, we have to throw an exception in this case as well. So the first part is easy. We just do songs dot remove song. And then before we do that, we have to do, well, so array list, I don't think this actually throws an error if like by default. So if you do pass something that's not in the list, it'll just do nothing. But for our purposes, we said we want to explicitly throw an error. So we'll just do like if songs dot contains. So if it does not contain song, then we're going to throw a value error. So we're going to do throw. That's how you write exceptions in Java. So throw new exception. I think that's how you write it. Yeah, we'll just go with that. Okay. Throw a new exception. Song not in playlist. Okay. Any questions so far? Is this too small? Maybe I can shrink this. It's fine? Okay. Any questions? Okay, yes. So again, this class is straightforward. It's not that complicated. Let's see. We'll do shuffle last. Shuffle doesn't return anything, so let's do shuffle random, or let's call it shuffle songs. So to do, let's do play next and play previous. So again, public void, because these don't return anything. Play next song. So what's going to happen in this one? Again, we're just mapping our MIS to code. I mean, you can almost just read it off, right? So pretty much if current song pause +1 is less than s dot, I think it's size, sorry, not s, songs dot size. Yeah, so size is what you use for array lists. Songs dot size. Then you can do current song pause plus equals 1. Otherwise, you can just do current song pause equals 0. Okay. And I don't think this had an exception. Oh, it does have an exception. Yeah. So basically, the exception is if the length of songs is 0. So we're just going to do if songs dot size equals 0. If it's empty, then we're going to do throw new exception. Let's just say empty playlist. And let's copy this over for remove song because it's very similar. Say play previous song. So what's going to be different about this method? It's just two things we have to change. Yeah. Yeah, so that becomes greater than or equal to what? Yeah, so that becomes greater than or equal to 0. What else? Yeah, so this becomes, instead of plus equals 1, we just decrement it. And there's one other thing. Yeah, so otherwise, if you're at the beginning of the list and you go back, you just go to the last song. So basically that would mean songs.size minus 1. So any questions? Everybody's good? Okay. Let's do size. Size is like, do I really need to explain size? I just do return songs.size. Okay, and now let's do shuffle. So we're going to cheat. We're going to do, so there's a built-in shuffle method in Java called collections. So that would mean collections.shuffle. And we're just going to shuffle our songs list. So we're going to cheat and we're going to do that. If you are interested in this and how this works, this uses what's known as I think it's called the Fisher-Yates shuffle. So it's like an actual algorithm designed for shuffling. and it basically gives you high probability that your elements will actually be shuffled by the end. So if you're interested, you can look into that. It's called the Fisher-Yates shuffle. It's also called like the Donald Knuth shuffle or something. Anyways, you can look into that if you're interested. This is basically how Java does shuffling. Now, if you were to do this manually, it would look something like this. Basically, you would have for int I equals 0, I is less than songs.size, I plus plus, and then basically we want some random, again, we had that random int function, so let's go ahead and use that. Again, we said we have a, let me go back to that. We got a start, end, and exclude. So let's write that out down here. It's public int random int, int start, int end, and int exclude. Now there's no built-in in Java that does precisely that, so we'll just leave this as is for now. We'll just do like return int math.random. So there's no function that does precisely this. So we would have to do like a for loop, keep generating until it doesn't equal the excludes one. But I think you guys get the idea. So we're just going to return a simple random number for now. So again, you would do random int starting from 0 up till basically, if you look at the MIS, let me pull that up. So from random int from 0 to length of songs -1, excluding I. So let's do songs.size -1, and we want to exclude I. And then basically you would just do, well, you would do song, a temporary variable, which is going to be songs at I. And then you're going to say songs at I. Oops. So you can't do this with array list. So you have to do get I. And we would do songs.set, set j, or oops, j becomes temp, and I becomes, sorry, I becomes, wait, what? Songs.get I. Oh, so it would be j, and then I would be, yeah, the temporary one. Sorry. This would be songs.get j. So I swap I and j, and then j becomes the temporary one. And then that's basically the idea. So any questions? Well, we're just going to cheat and use this. And again, that uses a specific algorithm known as Fisher-Yates, if anyone's interested. But this is the idea. And as for this, you would have to do something like while the random number generated doesn't equals excludes, keep generating until it doesn't equal that. And then eventually you get a number that doesn't equal the excludes one. So that would be the idea there. But I think should be clear. Any questions? Everybody's clear? Cool. So it's pretty much all for the lesson. I'll be here till 4:30 for any questions, anything. So yeah, see everybody next week. Yeah, it'll be posted.